Hello everybody and welcome back for lesson 3.10 or 3.10. Um, Again, so hopefully we're okay with most of the key aspects in this unit so far. Now it's just kind of like tying the unit together and a couple of extra extension kind of things that we will be doing. So this is technically not an extension as a part of the grade 11 curriculum, but we should have done some of this stuff before, and I think we know how to do most of this stuff, so it shouldn't be too hard. And technically this is also grade 11 linear quadratic systems. That's a bit complicated, but then inverse is something we've done before, and that's technically part of the first unit, and kind of extending into this unit is what we're gonna do. So again, that's just a brief. We're gonna get right down to it. This is not a very complicated lesson. I know I said that the last lesson was going to be short and then took like 40 minutes, but that was because, again, I spent a lot of time on homework. This is also a very short lesson, so not going to take too long, hopefully. So okay, let's take a look at this question. So a parabolic bridge over a river has a span of 100 meters and a height of 30 meters. What is the maximum height of a boat that can go under the bridge at a point 20 meters from the shoreline? Okay. So let's say there's like shore. So basically, like, this is the. That's not. I can't draw it like that. I have to draw a 3D river. I can't draw a 3D river, so I'm just gonna draw a bridge. So this is our bridge, and like this. So this is like one shore or one bank, whatever, and this is the other shore, and the other bank or whatever. And this entire thing is 100 meters. So if we say that, if we draw our axis kind of going like this, going up like that, we're going to call that 0. We're going to call the right shore 100. I scribbled too much on this, I guess. And our maximum height here is 30 that we are given. So what is the maximum height of a boat? So this boat is trying to go under the bridge 20 meters from the shoreline. So let's say this is 20. So the boat is not going to be able, it's the 30 meters is not going to apply because that's the maximum height, which, as you know, occurs at 50 meters. Well, that's important. We'll talk about why that is. But we want to find the height here. So what is this height? That is the maximum height that boat can have. So again, diagram is half the work, however shabby it might be. And the idea here is we are kind of given one piece of information. So, sorry, that was my cat just doing some gymnastics for some reason. Where was I? Okay. There's technically, I think, 2 ways we can do this question. Is there? Yeah, I mean, okay, I'm gonna opt for the more. So again, obviously we want to find. So what is our I said a lot of ums. And again, that's my like. I know, like, I'm sorry, I know, like, those of you who are listening to this video, like, I do say a lot. That's just a bad habit of mine. I try to get rid of it, but, like, unless I, like, really am consciously thinking about what I'm saying, I can't get rid of the So I apologize for those of you who are bothered by it. I am aware of the problem. It's just hard to quit saying So I have to consciously. Okay, whatever. We're gonna move past that, hopefully. So the idea here is that we want to find an equation for this parabola which describes the bridge. We're gonna plug in the point x. Let's say we're gonna say y is the height and x is the distance, and we're gonna plug in a point x equals 20. We're gonna find the y value for that point, and we have our answer. So first step, find an equation for the parabola. I'm going to start off you can start off in vertex form because you have the vertex technically. Technically I don't have the vertex because I just pulled 50 out of nowhere well, not really out of nowhere, but that wasn't given to me directly. So I'm going to start with y equals a times x minus 0 times x minus 100. This would be my equation of the parabola using vertex form, because again, my not vertex form, using factored form, because my factors are x equals 0 and x equals 100. So I have x times x minus 100. And now, again, I have to find my a value, and for that I need another point on this parabola, and I'm given my vertex indirectly because I'm given my two factors, and these are indeed symmetrical points. So my axis of symmetry is 50. I'm already given my maximum height is 30, so my vertex here is 50, 30. And I know that because, yeah, that's how I figured it out. I have given two symmetrical points, so I figured out my axis of symmetry, which is my x-intercept of the vertex, or not an x-coordinate of the vertex. So I'm going to substitute that value in. 30 equals 50 bracket, no, 30 equals a times 50 times 50 minus 100. 30 equals a times 50 times negative 50 is negative 2,500, I think, is 50 times 50, yeah. A equals negative 3 over 250. And I kind of knew that it would be negative because it's downward facing, because it's a bridge, and this kind of confirms my answer. A equals negative 3 over 250. So I have my equation, y equals negative 3 over 250 times x minus 100. That's my equation for my parabola. And now, as mentioned before, I need to find maximum height at x equals 20. So I'm just going to say y equals 3 over 250 times 20 times 20 minus 100. Y equals negative 3 over 250 times 20 times 80. I'm going to do some canceling. I'm going to cross off these two zeros first. And then I'm going to divide this by 5. I'm going to divide this by 5. So 80 divided by 5 is 16. And I don't think I can do anything else. So negative 3 times 2 is negative 6. Should this be negative 80? Yeah, negative 80. Negative 3 times 2 is 6. 6 times 16 is 96. So I get 96 over 5, which is approximately equal to, or actually it's exactly equal to, I'm too lazy, 19.2 meters. And this is now the maximum height. So my boat can only be 19.2 meters high. So that's my answer. And there you go. That was that. This is an easy question. What characteristics will the parabolas this parabola and this parabola share? You'll see here that they will share roots or zeros. And if you were to graph these parabolas, both these parabolas will have zeros of x equals 1 and x equals negative 4. So 1 and negative 4. The first parabola, let's call that A, will be upward facing and skinnier because it's a factor of 3. The second parabola, let's call that B, will be downward facing because A equals negative 2. And it'll be slightly fatter because it's actually a value of 2. Again, I've exaggerated the skinniness and fatness of these parabolas, but hopefully we get the idea. Technically, both of them are like pretty fat as far as things go. This 3 should be like super, super skinny, like something like that. But yeah, whatever. Again, these are fairly easy determining. I'm not even going to do all of these, I think, or I'm going to do them super quickly because I think this was one of the first questions we did on Friday. And Maya's my cat. She's on my table and playing with the computer, so I apologize. Shoo, Maya. Don't hit me. Go away. There we go. Sorry. So equation of the parabola, we did some very similar questions. I'm given -4 and 7, 0, which are my basically roots. So I can write x plus 4, x minus 7. Again, hopefully at this point we're good with, if -4 is a x equals -4 is 0, x plus 4 is a factor, and things like that. And yeah, hopefully we're good with that. So -6 equals a, 2 plus 4, 2 minus 7. Again, I'm putting this point into this equal to solve for my a value. And that's about that. So y equals 1 over 5, x plus 4, x minus 7. Again, hopefully we're good with all this easy peasy stuff. This is in vertex form, so I'm going to write this parabola in vertex form before I proceed. X minus 2 plus 3. Don't forget the squared. Very important. Substitute the point in. 16 equals a times -3 minus 2 squared plus 3. I'm not even talking. Hopefully this is all like, you all know how to do this. You can do this on your own. So y equals 13 over 25. X minus 2 squared plus 3 is my equation of parabola. So let's give the homework a quick checkout. Yeah, I told you, record time, 11 minutes and we're done. But there's a bunch of homework. So I won't be doing all of it, maybe just the hard ones. Page 192, let's go there, here we are. What do these have in common? So how are they same? You can see that they have the same vertex. This one's downward facing, this one's upward facing, this one's stretched by a factor of 3, this one's stretched by a factor of 6, that kind of thing. What do they have in common? You see that their y-intercept is common. They both have the same y-intercept. So determine equation of these parabolas, easy stuff. I will, in fact, actually work through 4D because that might be a bit difficult. So the x-intercepts are 1 plus root 2 and, 1 minus root 2 and 1 plus root 2. There's, how do we want to do? I guess we'll just do it the hard way. Y equals ax minus 1 minus root 2 times x minus 1 plus root 2. Hopefully we're seeing that, if we have a root, when we put that into our bracket, we have to change the sign. So you can write it this way because that's slightly more complicated, or you hopefully realize that, okay, this is our root. When I put it in a bracket, I'm going to change, so I'm going to say x, and then I'm going to change the sign. So this is going to be minus 1 plus square root of 2. This is going to be x minus 1 minus square root of 2. I'm going to change the sign of each of these terms. And now, of course, I know that it passes through 2, 4. So I'm going to put in the value here. 4 equals a bracket 2 minus 1 plus root 2, 2 minus 1 minus root 2. 4 equals a bracket, what is this? 1 plus root 2 bracket 1 minus root 2, which is nice because this is just a plus b times a minus b, which is a squared minus b squared, which is a bracket 1 minus 2, which is 1, so a equals -4, and I put that back all the way up here, I think, and then I get my equation of parabola. Vertex form, fairly easy stuff. We've done these. Determine the equation. Again, hopefully we're not confused with this kind of writing. F of 2 equals 3. That means if x equals 2, y equals 3. That's what this means. And y here being f of x, right? That's what this notation means. F of 2 equals 3. That means if I put x, if I sub in value of x is 2, this entire thing here becomes equal to 3. So a bracket 2 squared minus 6 times 2 minus 7 equals 3. Solve that for a. Determine equation of, just solve that for a and then just sub that back in to here and then you'll get your quadratic function. Okay, all this is easy stuff. X-intercepts are plus or minus 4, so y equals a x plus 4 bracket x minus 4 bracket, ta-da, that's that. This is, again, very similar to what we did above, so be careful about that. Here's a thinking question. I don't think we were supposed to, this was not part of the homework, as I recall, but we will consider it anyway, because that's a thinking question. So there's a parabolic arch 12 meters wide. Height of the arch, height of the arch, 4 meters from the left edge is 6 meters. Ooh. So again, we'll just set up an axis. We'll draw this arch. We'll say that the roots here are 0, and 12. And maybe I didn't stress this enough when I was doing the chapter. That's generally how we want to treat bridges and arches. If we're given like how wide it is, we fix the point at 0, one end at 0, and then the other end is. Technically, you could do anything you want. This is just the easiest method. And the height of the arch, 4 meters from the left edge. Be careful about the English here. Height of the arch, 4 meters from the left edge. So this is the left edge, 4 meters from the left edge. The height is 6 meters. Can a truck that is 5 meters tall and 3.5 meters wide pass through the tunnel? Justify your decision. So let's take an interesting. This is an interesting question. Okay, first, before we talk about the truck, you could do this the hard way. You could probably, find the equation for this parabola. You say y equals x bracket, like a times x minus 12 sub the point 4, 6 inside, and blah 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 blah. But okay, what are you really given? 5 meters tall, 3.5 meters wide. And ideally, the truck just has to pass through. We're not talking about where. So we want to look for optimum conditions. So the midpoint of this is 6, right? So it's 3.5 meters wide. So we want, 3.5 divided by 2 is 1.75. So this truck should ideally be passing through between 6 minus 1.75 and 6 plus 1.75. Why is it? Because that will give us the maximum height. Because we know the maximum height is at 6. Because that's the vertex. Because that's x equals 6 is the equation of axis. That's our maximum height. And to make sure that this truck passes, ideally, we want to have this truck symmetrically. If it's 3.5 meters wide, we wanted 1.75 here. So what is 6 minus 1.75? 4.25. So we wanted, the truck should be between 4.25 meters and 7.75 meters. So this is a gap of 3.5 meters, and the truck should ideally go through this gap, 4.25 and 7.75, in order to pass, because that's what's going to give it the maximum height. And we know that it's 5 meters tall, but we know that the arch at 4 meters high is at 4 meters from the left side is 6 meters tall. So at 4.25, it's going to be slightly more than 6 meters tall. And by symmetry, of course, on 7.75, it's going to be the same height as the 4.25, which is more than 6. So a truck that's 5 meters tall can pass. You can explain that in words, just like I did. You would say something like, that you would first establish this relationship. You would say the truck should pass from 4.25 meters from the left end to 7.75 meters from the left end. And based on the diagram, if the height at 4 meters from the left is 6 meters high, then the height at 4.25 meters from the left end, it will be more than 6 meters. And by symmetry, the height at 7.75 meters will also be more than 6 meters. And therefore, the truck that is only 5 meters tall will be able to plaster this arch. So you don't actually have to solve this question. Instead, you could just, do this kind of thinking. You will still have to find this 4.2, find 7.75, because you would so, okay, the way, actually, never mind. The way you would do it without all this thinking is you would find the equation, right? You would plug in some points. So you would say 6 equals a times 4 times negative 8, whatever. What am I doing here? A equals 3 over negative 3 over 16. So our equation is y equals negative 3 over 16 x minus 12. And now you would you would sub in y equals 5. So 5 equals negative 3 over 16 x times x minus 12. You would find your x values. So like the height of 5 meters, let's say here, and you would find your x values. Yeah, let me do this in another pen. This is like the method if you don't want to do all that logicking out. So at 5 meters, you would find the 2x values that go at 5 meters. You would find 2x values there like we've done before. And then you would kind of say, okay, take the difference in x values, and is that going to be more than 3.5 or less than 3.5? It will be more than 3.5 as we've already established, and so the truck can pass through. That's what you would do the long way. Okay, I'm just going to take a quick look at 15 and 16. Again, 16 is not that hard, really. And even 17 is just, you just plug in the 0.3, 6 into this, and then you solve for a. That's it. Not that hard. Same as parabola, except you just have one extra factor or whatever. We've done this question before. Parabola. Oops, it's not at 0, but we're going to say that's 0. This is 40. Determine the height of the bridge 12 meters in from the outside edge of the height 5 meters in from the outside edge. So that 35, the height is 8. So you have a point here that's 35, 8. Whoops. You can use that point to find the exact equation of the parabola, and you want to find the height that's 12 meters in. So once you find the equation, you just sub in x equals 12, and then lo and behold, you have the height. Not that hard. So yeah, those are fairly easy questions. So what do you know? Things like that, Yeah, I'm sure you'll be able to do 15. It's a good review. So I recommend doing 15. But yeah, that's it. So yeah, I will talk to you guys later. And peace out until next lesson. I'll see you guys later.